Recording is on. Hello, everyone. Welcome to the 19th of January, 2020. Well, it feels like 2020, but it's really 2021. And this is Dallas Personal Robotics Group, Robot Night Virtual. And my name's Carl Ott. I'm the president for second term here this year. And we're going to do what we normally do for DPRG on these COVID times, and that is invite people to speak about the projects they've been working on and what they're going to be doing in the next week. And if they have any questions or challenges, we love to stump the club. There's a lot of great experience here. So questions and comments are always welcome. I'm going to step out for a little bit. I might be back later, but meanwhile, you all can handle things on your own. And I think if I caught the hands right, what we'll do is we'll start off with Doug Dodgson. And then Pat raised his hand. Pat from Canada has something to describe, I think. And then I think Ray has something. And then after that, you're on your own. And Murray has something. So this is awesome. So, and Chris, look at that. Okay, so remember your sequence in line. And here we go. Doug, the floor is yours.
Okay, well, I promise not to take too long. I'm been working on, taking over the screen here, been working on the API that we talked about, and I've sent couple of documents to this mailing list. So anybody that's not in the mailing list yet, you can talk to Doug Paradis, I believe, and he can get you in the mailing list. You can email president@dprg.org or secretary@dprg.org, and they'll get you in that mailing list. And that's got all of our information that we're putting in about the API that we're doing for our telepresence robot. And I've also bought the bits and pieces for building this one for a first sample, just so I've got something to play with. This is something John Kay found. It looks like it's going to be pretty interesting. It uses, if I can get down to it without killing y'all's eyes, it uses Skype to go back and forth for the actual telepresence. And then it has an interesting tone mechanism for handling the robot commands. And it's a long article, as you can see, but I'm almost down there, I'm sure. It actually uses stepper motors for the motors too, instead of regular motors. I started to just put regular motors on it, but I thought I'd do it the way they wanted to do it first, just to see. And oh, well, I don't think it's even going to be on this one. It's a 7-part article, so I'm going to stop presenting. It's a 7-part article, so it'll be interesting to build it. And it uses a little bitty microphone with a Pi hat that can tell the dial tones from the phone. So you've got a phone keypad and you push a 1 to go right, a 2 to go left, that kind of stuff. And it hears it and it goes. So it'll be interesting when I get that put together. The downside, some of it's coming from overseas and it won't be here until the middle of March. So it's going to take me a while to get it put together. I'll give you all more updates as I go along. And unless there's any questions, that's it. I can pass it on to the next guy.
Can you make free long distance calls with it?
Well, it's Skype, so it's more of a VoIP, I think. You know, Skype.
Used to be, back in the day, there used to be. I'm just pulling your leg. Back in the day, there used to be a little box that you could make that would, I guess, it would go through a sequence of tones. And, and you could make free long distance calls with it. So. Oh,
that's right. Back before it became so cell phones could call everybody.
Yep. Yeah.
No, I think you're talking about a phone cracker.
Mm-hmm. I think so. Yeah. I think that might have been.
Doug, it was illegal.
Yeah.
No, I'm a rule follower, so I've never really heard about some of these things.
I think
this is different.
I don't know if they called those things, but I think there's something called a blue box or something that did something very similar to that. I've had friends where their doors had been knocked on by phone people. So traffic things.
Friends.
Yeah.
What it would do.
Pretty quick response from the authorities when you did that.
Mm-hmm.
The way those things worked actually was that the payphones had a particular noise that they would make when coins were dropped in. And so you could basically simulate those sounds and basically pay for a phone call before you made it. It would basically dial the phone number and pay for the call.
Now you tell us.
Yeah, well, you can't do it anymore, but
You can't find a payphone anymore.
Yeah, that's right.
There was a different one as well with shifted frequency tones for the different numbers.
Yeah.
And that was when you dialed the number from your phone, it used the local tones. When it sent it out from the exchange, it used the shifted tones. So when you use the shifted tones right from home, you bypass the local exchange and it went straight out.
Oh. DPA wants in, John.
If you go look at the chat, I left you a link there. There's a meeting tomorrow night, online, of course.
Is that the mobile.net?
It's a meetup. No. This is through the dev show.
Okay.
It's all about SignalR, using it and not making a chat client, using it in the real world to do other things. Yeah.
Cool.
That's the very first link in the chat up there I left. So that might be of interest to some people. It came across my feed today, and the current client that I'm on, we're like, ooh, we need to watch that because we're doing some of those things. See what they say. Yeah. And the speaker on there, Kevin, he's been around a long time, and he's a really excellent speaker and knows many, 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 many things. What's got going on there?
So I guess I'll turn it over to Ray. He had his hand up. I know a lot of other people did too, but he's up at the top on my screen.
Okay. Anyway, I have been working on yet another robot platform.
Yay.
Yeah. Anyway, this one is to replace the Rami, which has quite wide wheels and is not that fast. And I have, there's the Rami base, and there's an OpenMV H7 on top. And so I'm replacing it with another platform. I think these are actually the motors from the Balboa robot, and they're like right angle, gear motors, and you can stick encoders on the front, which is really nice. Anyway, so it's going to be run on 2 lithium-ion cells. I went with one of Adafruit's. Let's see, this is the Adafruit Motor Shield version 2.3, mainly because I didn't want to do that much soldering, and basically it only, takes 2 pins off any processor. This one was made to sit on an Arduino. You can get them for the Raspberry Pi, and I think the Feather has one now. They're all pretty much the same. They have a pulse width modulation part that I think generates PWM out of 16 channels, and it's got 2 TB6612s on it, which one of them you can drive 4 DC motors with it if you want, but I'm only driving 2 because it's a differential steer. Anyway, what I wanted to do is bring in or make the wheelbase narrower. So this is just under 4 inches now, and whereas the Rami was I think over 6, and I should be able to make turns much quicker and go faster because these motors are geared down less than the ones on the Rami. I think they seem much faster anyway. So I've gotten, the motors wired, the encoders wired. I figured out, if I make the motor go forward, does the encoder cap increase? I had to fix that. So I'm going to port everything from the Rami platform over to this one, and still use the OpenMV H7, and just see if I can get better results than what I got with the Rami on the challenge line following course. So that's what I've been working on.
That seems pretty cool.
Yeah.
So Ray, you're using it for the challenge fine course? Is that?
Yeah, I
is
just
that
wanted a
the
narrower
purpose?
wheelbase. You know, this is right
I
at 4
understand.
inches, and
Mhm.
I can't really change it on the Rami. It's I think it's actually like 6.5 inches, if I'm not mistaken. I haven't measured it in a while, but a lot wider, and I had to, you know, I can only go so fast with. Actually, it's just a little under 6 inches, maybe 5 3/4 or so. But now I'm just a little bit under 4, and I could go narrower, but 4 seemed reasonable with the size wheels that I could accommodate. But those motors.
How about balance? You have any trouble with balances? With balance?
No,
With
not
the
right
camera
now.
hanging up?
It's kind of back-weighted. I have a metal caster,
Caster.
metal frame, and so the balance is actually pretty good. I've got the battery compartment underneath in the back, behind the back wheels. So, and right now it seems like I can, you know, that's the other consideration is, you know, you don't want the thing stopping quick and flopping forward, or I guess doing a wheelie or something. But
You
all that
know
seems pretty
about
good.
the T energy batteries, right?
You
you're
know,
going for the 18650s.
Yeah, I was actually using I think they're Panasonic 18650s.
Okay.
They're the ones in the red heat shrink.
These guys, I will say, these guys are really, they're 3,500 milliamp hours, and they really are 3,500, 3,500. They really are good batteries.
Yeah.
So those are the ones that Carl turned me on to, and you can get them both in the protected and the non-protected form. They have a couple bucks difference price.
The 18650.
And they have 10 hour. Yeah, and they have 10 hour. They're high current draw, and instead of 1 or 2 amps, they can allow you to draw 10 amps out of them. So I guess that's what about 3C?
Yeah, probably.
So I'm just saying they seem to be really nice. The problem with 18650s is, for me, I'm either using old used ones out of laptops, or they're you buy some from questionable sources, and they say they're 10,000. Well, they can't be 10,000. That's kind of like a turnoff. So 2,200 seems to be normal, but these are actually 3,500. So they're really nice.
Did you get them from Fry's, or where'd you get them from?
Well, I got them from Fry's, but Fry's is pretty much dead meat. So
you ain't getting them there now, I'm sure.
But
so
with their T energy, yeah, I'll put them in the link. Their item number, pretty nice. You can look them up.
Yeah, there was a guy that did a thing on batteries from Chinese suppliers, and he said anything with the word fire in it should be avoided. And he actually took a lot of them apart, and there'd be like you'd have a mostly empty case with a little bit of battery in the very center of it. So you can't really expect it to do or to have the capacity that it claimed to, or to last very long. It was like an 18650. The inside of it was actually smaller than a AAA battery. So.
There's a cat on YouTube called Big Clive. If you never watched his video, and
I love Big Clive.
Yeah, he tears apart all kinds of things. It's amazing. It's amazing what he finds in this thing that you paid $20 for is literally a capacitor and maybe an LED or something. The whole thing. They're in a dime worth of parts in the whole thing. And some other stuff. He's a real interesting fellow to watch. Big Clive is a guy to watch on YouTube.
Ray, what do you gain by going to a narrower wheelbase?
I can turn much faster. You know, with the wider wheelbase, if I didn't want to spin one wheel backwards to make the tight turns, you know, I have to go pretty slow. So with the narrower wheelbase, you know, since your wheels are much closer in, you know, there's not that great of a difference for, say, like, you know, some of the 180-degree turns that are on the challenge course. So, but with the Romney platform and you know, a wheelbase close to 6 inches, one wheel wasn't spinning at all, just the one was being driven to get around it. So, and you know, I didn't want to go backwards to try to keep up with it. You know, to try to follow the line. So
Why do you not want the inside wheel to go backwards?
Because it slows it down. If you know, if one wheel's going backwards, you're basically rotating in place versus both wheels moving forward. And you can, you know, the closer in your wheels are, the more you can do that. I guess you know, get to a point where maybe they're so close that the thing doesn't, you know, stay upright very well. But so yeah, I just wanted to see what that was going to do for me. You know, the motors are faster. You know, the maximum speed is faster. And you know, you know, Carl has a narrow platform. Clay has a narrow platform. Mine was quite a bit wider. Doug, what were you using for you ran the challenge line following course, didn't you?
No, I have a robot that I'm planning to do it on.
Oh, okay.
It's a 6-inch wheelbase, or maybe just slightly less than 6.
Yeah.
It's got the Max Pi. Is that what it is? Max Pi.
Okay, yeah.
Instead of
the OpenMV H7. Yeah.
Yeah.
Here's a dumb question. Oh, when you guys are measuring wheelbase, is it the outside of the wheels or the center of the wheels?
Center. I do the center. Yeah.
Okay. All right. Thank you. I was just gonna check what mine is.
Yeah, Clay could zip right along with his little platform. It was pretty impressive.
Is that
Anyway,
it, Ray?
all I had.
Okay, I can go next, if that's all right.
Sure.
So last week, officially, my ship came in. So I'm just going to switch cameras.
I wonder if it's heading to Texas next. I still haven't gotten parts I ordered before Christmas.
Oh, what parts did you get?
So, got the new driver board. Got it wired up. And I don't know if we can get that there. Start it up. And we're able to send it a command. Oops, need a battery. So we have wheels spinning.
That thing is loud.
Oh no, hang on, I'll show you loud.
Hold my beer.
I'll show you loud. So that's loud.
Bad about my motors now.
That'll keep the moose away from your house.
So what type of motors is that we're hearing?
That's an RS 550 motor. Flat out, it runs at 19,000 RPM. And it's going through a 132-to-1 gearbox reducer.
So that's where we're hearing the gear noise.
It's
Okay.
the planetary gearbox that's really loud. And I think those gearboxes and everything may get converted to an outdoor robot at some point, where noise is less of a problem.
Are you supposed to lubricate the?
Yeah, I have some heavy duty lithium grease inside the gearboxes.
And it's still that noisy. Wow.
Oh, it's still that noisy, yeah.
There you go.
So after it runs a little bit, I'll tear them down and I'll see if there's any, if they're lubricated enough. But I packed them pretty full. They're packed about, I would say half full of grease.
Wow.
And so I got the motor driver working. Unfortunately, I got to rip it apart. I got to get at the encoders, and I'm going to solder the differential pulse wire on the encoder, or the opposite pulse, the B channel. I'll solder it in. I'll bring it up to the board. I have a proto board coming. I'll make an adapter board so I can plug in the encoders and be set to go with the PID loop. I have been working on, I have a remote for it, a PS3 style remote, and it uses a little USB adapter. It's got a proprietary radio signal in there. But the problem I'm having is the deadband on the joysticks is quite large. So I don't know if it's the wipers on the pots inside that aren't working right. So it'll only pick up once I'm about a third to halfway up, let's say.
Hey, Pat.
Yeah.
I've been using one of these 8-bit do ones. They come in different colors, and they use Bluetooth. And so when you're using the joysticks, the center position is 128. If you pull it all the way back, it's 0, and push it all the way up, it's 255. And that center position is effectively a deadband, of course, at 128, and it vibrates around that a little bit. And so I've just programmed in a little bit of hysteresis around 128 to cause it to go to 0 if it's near there.
Mine is rock solid at 0.
Okay.
So I've got to move quite a bit off of 0 to get it to even move. The other problem I'm having is trying to find a program in Python. I've been trying Pygame. I've tried a couple to get some input in, and so far I've had no reliable luck.
Well, the one thing that I found was that, of course, this is Bluetooth, and what I did is that there was documentation on this thing, but it's not obviously designed for robotics or Raspberry Pis or anything. So all I did was I just captured the signals, and you can go to I'll put the link in, but I've got a gamepad Python class that I wrote that actually captures the signals coming off this thing. And all I did was push each of the buttons and see what number it was that was getting the message that was being sent. So I just literally kind of hacked the whole thing and came up with a way that this particular device works.
Okay. When I use JS test in the terminal, it works perfectly fine.
Oh, okay.
It's when I'm trying to bring it into Python that I'm erroring out. And
well, I'll put the link into my library and just there's a lib directory, and in there you'll find some gamepad labeled Python classes. You might get something from there. I don't know.
Okay, so far I'm still trying to stay away from ROS2 if possible, but it does make things handy for background communication on different between programs.
You said you tried Pygame and it didn't give you the joystick. Because I'm just looking at some code that I used, or a sample code that I found. And I can't try it right now, but it's referencing Pygame, so I'm pretty sure it's supposed to give you the joystick, events. And you're saying it didn't work for you?
Yeah, so I've got it in there, but the joystick event keeps erroring out. So what I'm going to do is I'm going to take it back to just a basic program with just the joystick and see if I can get that working reliably. The problem I'm finding, a lot of it was written originally for Python 2, and when you run it in Python 3, you're getting sporadic errors. Okay. And I've had that on a bunch of base code with no modifications.
Good. Now, one comment on joystick and Bluetooth, and I don't know, Pat, if that's you didn't mention anything about Bluetooth, but Murray did. One issue I found with Bluetooth, once your robot's a little bit away from you, well, you lose your connection. So what what I've done in the past and usually do is I have the Bluetooth connection to my laptop, and then from there I relay the information over Wi-Fi, right? Because then it does, if my robot's all the way down the hall, and I'm not saying it's going to be a mile away, but even if it's just the opposite end of the house, I can still use my joystick because ultimately the information is going there by Wi-Fi. I'm not going to get a Bluetooth link all the way to the other side of the house. So.
Yeah, so that I agree. It's Bluetooth. I've had different models I've been working on, and with Ubuntu running on the Raspberry Pi, the Bluetooth does not work very well. I've compiled it, got it up and running, and it still managed to error out. And then in Raspbian, the best I could get with my Bluetooth remote controller was about 6 feet.
What I found was, I agree with you guys that the native Raspberry Pi Bluetooth is pretty weak, but I bought one of these little guys. I don't know if you can see that, but one of these little dongles. And I just plugged that into my Pi, and that gives me, I don't know if you saw that video, guys, I did outdoors, but I was about 25 feet away from my robot outdoors and didn't have any problems at all once I started using the dongle. So I think it might just be the actual antenna on the Pi is not very good.
Yeah, I've had some of those dongles go to 100 feet or more. But
yeah, it's really good. About $10.
It was definitely a powerful thing. It wasn't the built-in Bluetooth, though. I'll guarantee you that. It wasn't just the built-in stuff.
So the dongle I'm using came with the remote, and so it's proprietary. I don't have to sync it up, and it works very reliably and at a good distance. It's just the getting the joystick signal to behave in the Pi game right now. So, and it's a standard PS3 knockoff Chinese version. And actually, the controller I got from Robot Shop. So usually they're selling pretty good stuff.
Mm-hmm.
So that's it for me.
I'll go next. So there's some Adafruit products that you guys have been talking about a number of times, and I don't know if this is in focus, but what it is, it's a Cutie Pie that Murray has talked a lot about.
Oh, yeah.
And the B&O. So here's the Cutie Pie, Cortex M0 Plus, super, super small form factor, as you can see. I mean, tip of my finger covers it up. And that's a B&O 085. A number of you guys have been talking about the B&Os. So I thought I'm going to try those out myself for absolute, heading information. And, the Cutie Pie, the reason I got that one is, just maybe another way to extend the I/O of the Raspberry Pi, either by using the USB or over I2C. But it's just such a small form factor, and I don't have a lot of room on my Romy. And so it only has 11 pins. 2 of those are I2C. That leaves you another 9. All of them can be analog inputs, and I'm short on analog inputs on my Romy. So, so I need to try, I'm thinking of different ways to expand the analog inputs, and they have all kinds of I2C stuff and muxes and whatnot. But I thought the Cutie Pie is maybe a interesting way to go, very versatile way to go. What I'm finding though, and again, I have it hooked up to the B&O 085, and it's running some of the sample Python code. It doesn't really have enough memory to run, all the Python libraries that come with Circuit Python from Adafruit. So, for example, the standard way you talk to the B&O 085, you can't even run that Python code. You don't have enough memory. Well, I mean, there's a simple way to interface with the B&O, which I'm doing here, over just a UART link, receive only. Just the B&O, you tell it just spit out the data. That library can run in Python. So what I'm finding is, running Python on that Cutie Pie, it's you can do very simple things. It's very convenient. I was going to say that what it reminds me of, Python in general, what it reminds me of, and I don't know if any of you guys know that stuff from MIT, Interactive C. Does that ring a bell with anybody? The Handy board and the 6270 board. Well, that stuff was fantastic. I mean, it was that slow, but that, Python reminds me a little bit of that C interpreter that they had way back when, on those MIT handy boards and 6270 boards. And when it comes to Python, I mean, that interactivity I sometimes value. Other than that, I'm not such a huge fan of Python, but the interactive nature of it, and is sometimes convenient. So I'm dabbling with that, trying to figure out how good of a heading I can get out of that B&O 085, and how it compares to the gyro that's on my Romy, right? The Romy control board comes with a 6-axis, but I don't remember what it comes with, but basically it includes a gyro. So I'm gonna, if I have time, compare the quality of that and see what that gets me in terms of improved odometry. So that's one thing. I also bought this one from Adafruit. Again, you can't see it, but it's MCP 2221. It's USB on one end. You can plug it into your laptop, and then it's got I2C, UART, GPIO interfaces. So you basically you can run Python code on your laptop under Linux, and you use this as the I/O interface, right? So the Adafruit Circuit Python libraries, you can just use them and pretend you're running on a microcontroller. But in reality, you're running on your Linux environment, but it's talking to this USB gadget, and it becomes the I2C interface. It becomes the GPIO. It wasn't really, I mean, I tried again interfacing. I tried to then connect the B&O 085 to the I2C port of this guy. I did, it was sort of working, but I ran into some issues. So I'm not sure if this is working bulletproof yet, but I found that interesting, right? Because it does open up some prototyping, avenues for doing stuff on your laptop, but you need an I2C port somewhere. And it makes it transparent, right? Because you can run a piece of Python code that's opening up the I2C library, right? And talking to some I2C device. And that exact same Python code could then later run on your microcontroller or on the Raspberry Pi or, on the Cutie Pie or what have you. So that's why I found this interesting. And it was only a couple bucks. And so I decided, make sure those guys stay in business, gave them a couple dollars. A lot of you chimed in on my question about how to create a line following course on the floor, and I really appreciate that. And I'm just going to move my camera here because I've been trying out a couple different things.
I was going to say, you probably got more suggestions than you ever wanted, right?
I don't know why that video just went away. Hang on.
Would we do something?
I'm taking that a little too.
I asked for a cup of water and you gave me a swimming pool full. Who does that?
Wait, it decided to kill my video. Hang on. Okay. No, that's the wrong camera. Sorry about that. I don't know what it's doing right now. Okay, it's having a mind of its own. I'm not clicking anywhere. So you can see a couple different experiments with different types of tape going on here. Okay. Tape on top of some substrate going on. This beige one right there is actually delicate surface painter's tape underneath, and then something else that I had on top of it, because that purple one, wasn't giving me any good enough difference between the tape and the hardwood floor. So this is actually 2 layers of tape there, and it sort of works. And then I'm gonna leave it on for a few days, and then leave another piece on for a few more days, and just see how many days I can safely leave it on. That's what I'm trying to figure out. Then the other tape I found is called artist tape. It's also supposed to have a very delicate very delicate adhesive. It's meant to go on top of like audio mixing equipment, and it's not, you don't want it to damage the plastic. So I'm experimenting with that tape as well, and it's just the right size and the right color. It's a bright white, so it gives me good contrast with the floor. But as you have seen in my last email there, my floor has quite a range of color to it, right? You can see that. So I get a good difference between the floor and the tape, but I'm not getting a crisp edge, right? And so I'm having a hard, my robot's like, it's doing a little bit of an oscillation thing there. I'm not sure oscillation is the right word, but it's just getting confused by the fact that as the line transitions onto the floor, it's occasionally picking up some real dark spots, occasionally some real bright spots. So I don't know. I may have to just accept that that's good enough, because I really like the convenience of that tape. I mean, assuming for the moment that I can leave it on for a few days safely, I really like the convenience of that tape. To create a little course and around the house for collecting some LiDAR data in a semi-repeatable fashion. And my thinking is I create the occasional marker like that, okay? And when I cross over the marker, let's assume I know where that marker is, right? I can keep track of absolute position that way. So that's kind of the thought process right now. And I just have just to figure out how to calibrate everything for this tape and the floor. Just have a little course here, and it does its thing. And the problem I talked about is probably not going to be evident here. It'd be more evident if it was a straight line, but so you're just going to have to take my word for it when I say that it's, even when the line is 3 feet of straight line, it's having difficulty. It's having difficulty really seeing a straight line there because of the the pattern that's in the floor. So again, maybe I just have to accept that as a limitation. But because I'm planning to collect LiDAR data, maybe some sonar data, I don't really like the idea of my robot going like this, right? Because that makes my my sensor data more noisy than necessary, right? I just want to go in a smooth straight line. And again, that's what I was hoping to achieve by putting a line on the floor. Just have it go a smooth straight line in a repeatable fashion and collect some data. And so it's not giving me that. So either I accept it as is, or I put the white line on top of something else, like some of you suggested. So I may try that as well. But takes away a lot of the convenience element of just putting a piece of tape on the floor. That's my problem.
Chris, I was thinking about your problem, and one of the things that you can do with with a robot like what you've got is you can definitely put PID loops on if all you want to do is go straight. All right, you really want to just go straight, you just put PID loops on them and keep your encoder counts the same, and it'll drive straight. So you could like put it a certain distance from the wall, and you could actually use 2 little tapes to be your start marker and your end marker, and use your line following sensors to stop you, so you just don't hit into the wall. And you just set it straight and just let the PID take you straight across in a straight line. Now, once you start adding turns and stuff to it, it's going to be, each one is going to be a little different from the next. Each run is going to be a little different. But if you're just going to go straight, that's not too hard to do.
No, there will have to be some turns. Otherwise, I won't get enough value out of this exercise. There will be turns.
Okay, well, you could try. Okay, well. Anyway,
So what
are you using a Raspberry Pi and a Raspberry Pi camera?
No, this is QTR. So this is the Romy, and where's the QTR? This side. So oh, cute! You can actually see the IR LEDs. Yep. So it's the 8 array sensor. I only have 6 analog inputs. Like I said earlier, I'm short on inputs. So I hooked up 6 of the 8 sensors here. And that's, it's quite tricky, as I found. And I think, Doug, you mentioned that, Doug P., right, getting the right distance off the floor is actually tricky, right? Again, because my floor already reflects 50%. So I have to tweak this just right so that I don't pick up too much signal from the floor, and I want to get a clear delineation between floor and tape.
Let me show you my sensor and give you some ideas.
Well, Doug's going to get his. What I did for my course was I tried, behind me, you can see this big white piece of styrofoam. It's from Home Depot. It's a piece of insulation coming 4x8. And it's like $10 for a 4x8 piece. Yeah. And I cut it up and then I painted it. Actually, I got my assistant to paint it, and she never finished it all. But
the reason so what I'm planning to do is actually have my robot go out that door, go down the hallway, go to the other corner of the house, right, and collect LiDAR and other data along the way. So I can't make a small stationary course. I mean, I need to cover 150 feet of ground.
Yeah.
So, Chris, here you can see I don't know if you can see it very well. I'm trying to get it.
Let me pin you.
It's a black piece of plexiglass with holes cut out for each of the sensors.
Oh.
Okay. And so it literally almost drags on the only thing keeping it off the floor is a width of a paper clip.
Mm-hmm.
All right. And the black plexiglass keeps the sensors from cross-talking.
Okay.
Okay.
Interesting.
I might have another one that might be easier to see. Give me a second.
Yeah, that eliminating the crosstalk. I mean, I got to try that. I can't go that close to the floor though, because then I'm going to get 100% reading right from the floor, right? Again, because the floor is reflective. If I get too close to the floor, everything looks the same. I got to stay away from the floor, 5, 6, 7, 8 millimeters.
I don't know if this one is any better, but can you see the holes for the different?
I can see the holes. Yes.
Yeah, this one is this is actually a piece of masonite. Okay, and now this one is actually riding a little bit higher off the floor, but the effect is if you can look, you can see that it's kind of like a double bend of a paper clip. And this one, it works too. So now one of the things that you can do this in a couple of ways. In this robot, and I'm not saying this is the best way to do it, but this is how I did it. In this robot, it actually has a couple of comparator. It has 2 quad comparators on it. And I'm using the quad comparators, the input to the quad comparators. And there's an adjustment. I can't remember where it is, but there's a little adjustment to make on it. So it's taking your analog and turning them into digital inputs. And that's cool and it's great, but you lose the analog information, which can be of value. All right. It's harder to set up, but this way you can use your digital pins and you can use all your sensors. This robot actually has 10. I actually took 2 of those and hacked off the little two sensor part, stuck it on the end. So this one has 10 sensors in it to give it a little more reach. But the newer sensors from Pololu have more reach just because they were designed better.
Yeah, I have one of the older models that I bought years ago.
Yeah, so that's what I have a lot of those. I use them fairly regularly on this type of robot. But anyway, so it's a good sensor. There's nothing wrong with the sensor, but you do have to, there's a few tricks to it.
Yeah, I think from looking at the data that's coming back, and occasionally it's like, again, I don't, have a couple of sharp turns there, but even some of the not so sharp turns occasionally does a loop-de-doop. My camera is passing out again for some reason.
Well,
And what I then, when I looked at the data, what I noticed is, one of the sensors, again, some spots of the floor are just highly reflective, right?
oh yeah, in vinyl is even worse.
I pick up a false reading,
Yeah.
and if I'm going straight, okay, that's going to turn into a little very intermittent kind of, wobble.
Well,
But
I mean,
if
it's
I'm in the
working.
middle of a turn, that false reading is sometimes enough to just throw me off course.
Yeah. Hey Chris, what's your lighting like on the areas that tend to screw up? I mean, is it kind of diffuse and or it looked like you had those we call them pot lights in Texas on your ceiling there. Is that?
Yes, that's pretty much going to be the case. Even in the hallway that's outside my office here, there's pot lights everywhere. Some of the rooms that I might go into with the thing won't have pot lights, but let's say mostly pot lights.
Yeah.
Did you consider a different color tape?
Well, again, the tape is not the problem. I'm getting 100% reflection on the tape because that was white tape, right? So when I see the tape, boom, I get 100%.
I was just thinking about comparative to the floor.
Right. So I get a strong signal from the tape, right? I mean, if I were to look at literally just the A to D counts, I get basically 1024 when it's open air, right? When I see literally nothing, I'm close to 1024 maximum at 12 bits, or whatever that is. I don't know, 10 bits. When I'm picking up the white tape, I'm at 35. Okay, so but when I'm on the floor, okay, so when I'm on the floor, I'm sort of in the 400 range, but again, some sensors are more sensitive. So one of them is picking up a 250, right? Still, I mean, it's 40 when I'm on the tape, and let's say anywhere between 250 and 450 the floor. There's enough of a difference. I can pick up that difference. It's just occasionally there's a piece of floor that's so reflective that there is no difference. That seems to be my problem right now. Occasionally I'm picking up a strong reflection, and then it's just, I can't filter that out as easily. I'm playing with different thresholds and different things, but that's I think my challenge. The floor has a broad range of reflectivity depending on where I'm at.
Well, Chris, it sounds like your real problem is the floor. I would just go out and get some flat gray paint and paint it.
Yeah.
I was wanting to say that, and I didn't.
Chris, looks like the sensors are quite some distance apart. I wonder, you're using the edge of the tape as the reference, right? So how sensitive is it that you can detect the edge, or shifting the edge? How sensitive?
No, so what I'm doing is I'm using the same principle that the Pololo 3 Pi was using, which is it's looking at the different readings here. And again, I'm using just 6 because that's all I can read right now. And then it's doing a sort of a little bit of math to sort of add up all the readings. And what you get in the end is basically if I get it translates basically all 6 readings into a single number. If that single number is 250, that means I'm in the center, which is kind of actually between two centers. If I'm 0, that means I'm all the way on one side. If I'm 500, I'm all the way on the other side. So
it's like
I didn't come up with that logic. Pololo did, and it makes life very easy, right? Because that way I know right away if I'm reading a 250, that means I'm kind of really on top of the line there, and both senses are seeing the line. And so I have a single number that immediately gives me the error if I'm too far to the left or too far to the right, right? I don't look at the
what if what if your robot shifted, say, half a centimeter, but no sensor is detecting?
Okay. So
because
what again? I didn't come up with that trick, but the trick is if you suddenly lose the line, you look at all your sensors. Hey, if none of the sensors is registering a solid line, that means you've just lost the line. If I've just lost the line, I'm just gonna ignore this reading and keep doing what I was doing a moment earlier, right? So if a moment earlier I was seeing the line over here, and now it's gone, well, I'm just gonna pretend the line is still on that side, and I'm just gonna keep turning until I see the line again. It works 90% of the time. I mean, it doesn't work in something like the challenge course with different colors, but on a basic course, right? Even the 90-degree bends, that's what happens. And when I reach that 90-degree turn, I lose the line, and then but it knows where the line was a moment earlier.
So when you said lose the line, are you saying that effectively your number is the same across the board? Is what the glare or you're saying you're getting glare on certain spots. So I'm thinking Doug idea of having the sensors separate from each other, that's a good thing. I also would think put a light on there to substitute, because your overhead, you have certain spots where you may not have a light shining down, and other spots you do. So that would eliminate that glare. If you have
Well, the sensor has its own illumination, right? So it has its own illumination.
Right, and I'm thinking that's why having the paper clip separation between the cells is probably the best bet. I would try that out.
They'll help you out on that, Chris. They'll give you a lot more robustness.
David.
It sounds like the places where you're getting the aberrant detection are specular reflections. And specular reflections are highly dependent on the angle. I don't know if this is doable with your situation, but I wonder if you could angle that sensor forward a little bit so that you're not getting a reflection directly back into the sensor. So the specular reflection would tend to bounce away from you rather than back toward you.
I will try that.
That's a good idea.
I wonder if, so you're talking about on a straight line, on a straight section, it won't stay straight, right? I wonder if this is what's happening, that you always have some error, right? But then when it's shifting, that edge is in the middle of the two dots, and it doesn't know until it sees that when the edge.
Well, I mean, I'm getting analog readings, right? So I can tell if I'm I don't know how to best show this, right?
It is analog.
If the tape, which is about as wide as this thing here, right? If it's covering up exactly one sensor, I'll get 100% reading on just that sensor, right? If I'm like,
I see.
The tape is in between two sensors, well, I might get 100 on both sensors or a 95 on both sensors, right? And again, this little math trick that Polo Lou has there kind of, again, translates this all into a single number in the end that kind of corresponds to a position. So it works very well, as long as, it works very well on, let's say, on a course where you have black and white. That's it, right? Because you don't have all this noise going on, where all of a sudden on the edge of the sensor, if this is the tape, on the edge of the tape, sometimes I get a reflection that's just about as strong as what I get from the tape, right? It makes it look like the tape just moved, right? That's what happened. It makes it look to my senses like the tape moved a little bit, or the tape got a little bit wider, right? And that's what I need to eliminate. And I'm going to try what Doug Pratt is proposed, and what David Anderson suggested. So I think I'm going to play with those ideas.
What if you draw a thin line on the tape that you're following that thin line? Can that be? I mean, not your sensor, but maybe a different type of sensor. But basically, your tape is your background, and there's another line on the tape.
Well, that was suggested in the mailing list as well. Basically, use a 2-inch white tape, contrasting color, put that on the floor, and then put a 1/2-inch white tape on top of the 2-inch white tape. So I think that's, if I find a 2-inch white tape that's dark enough, or if I find the black and white opposite tapes and the white one is safe for the floor, I might consider that as well.
Well, your black line, Chris, can always can be electrical tape if you're putting it on tape. So if
Right.
you
So
had,
whatever I put on top doesn't matter exactly. Whatever I put on top could be any kind of tape. I don't care about the adhesive, but the one that goes on the floor, I guess I'll have to find a 2-inch wide. Again,
painter's
either
comes in all sorts of sizes.
Yeah,
And
you
you
can get
might
that up to 3 inches, I think, even.
you might be able to get a white painter's tape. I just know that it's not as common as the blue. The blue is what I always use. I always have blue painter tape. It's great for all sorts of stuff.
Yeah.
But,
You also might try gaffer's tape.
that could work, or it could backfire. Right?
That's pretty sticky stuff. And you don't have to do like, if you get enough tape, you don't have to paint your floor like Murray says. You can just tape your whole floor. It comes up after that. Yeah.
The thing is that gaffer's tape tends to have a more appropriate adhesive that doesn't either stick too bad or pull stuff up or leave stuff behind.
Yeah, I think it was Kareem that brought it up. Actually, gaffer's tape is made to stick to itself. So if you ever get it stuck to itself, you fold a piece over, you're not getting it off.
I agree, but gaffer's tape will stick down to floors and wood and stuff like that. It's just that it's intended to not be too invasive.
Right. Yeah. I agree.
Chris, I was trying to see if I can see here, and I can't. That's a tile floor, and I was going to show you the nasty, sticky stuff that was left from years ago when I put down just regular masking tape and left it down for a month. Oh, I lived with it for years after that. So
That's
No
called
masking.
That's called
these are beautiful wooden floors.
Yeah, and I've pulled up the polyurethane on a floor before in my old house, and I don't remember what tape it was, but I left it on there for too long, and it pulled up the finish, the glossy finish. So
Yeah, that blue painter's tape, if you leave it on long enough, it'll do that too. So it's not that, pretty much all those kind of tapes, you leave it on too long, it'll do that unless it's specifically made, like a Post-it note or something.
Yeah, I think a lot of them are rated.
You just do lines of Post-it notes. You get a whole Post-it note that is all coded in the back and just do lines of Post-it notes. There you go. Okay, maybe not.
Even Post-it notes can get pretty sticky.
all right, a couple good suggestions. I really appreciate it, guys.
Yeah, the sanding the floor one, I don't know about that.
Who else wants to go?
I can go next. I've been kind of busy in the last week. Let's see. I'll start with the new acquisitions. I think I mentioned that I put an order into a company called Nuvoton, which makes the I can find one of these
displays.
It makes the little tiny processor that goes on this board, and the little processor is 3 millimeters square, and that's an 8051. And so I decided to buy one. Now, one thing I didn't realize about the Nuvoton products is that it's one of these things where, like, what's that thing they put on mirrors about when you look in the back, the objects appear larger? Well, they're bigger than I thought. So the board that I thought I was buying turns out to be this one. I'll flip my camera around so I can see what you guys are seeing. Okay, so this board is actually quite large. It's not a tiny board. I mean, you only need this part of it because that's the actual board, and this is the driver for the USB program loader. But this is an 8051, so that's like a 1980s era programmer on that thing. You can program it in C++, but I haven't tried it yet. I've been too busy with other things. But the idea is that I'm going to plug this thing into my Windows box, which I don't really have. I have a little Windows box. and program it directly and then see how it goes. It's got quite a lot of pins for a small board, but maybe not as many as any of the actual tiny boards. But that's my one board that I bought. Then I got two other boards, which are interesting. One of them, let's see if I can find it, is the, oh, where did I put it? Oh, here it is. I mounted it on a piece of plastic. This is the Nuvoton Chili, and that's 50 millimeters square, and it's I don't think it's an ARM processor. The top board comes off, so you get a little carrier board for the Ethernet, and the board itself is there. And this is a Nuvoton ARM something, I can't remember what, but it's basically a little more powerful than a Raspberry Pi Zero W. Doesn't have an SD card on it, so it's actually got, it's actually already got a version of Linux built onto the board. And I haven't tried it out yet, but basically it's an embedded processor test board. I mean, these are all development boards, and it's got quite a lot of little features. It was about $15 or something like that. And then the other one where the object was larger in my rear view mirror, I thought this was going to be about the same size as the Raspberry Pi, and I didn't obviously read the TF manual. But this is, so here's just by means of comparison. This is the Raspberry Pi B+, and this is the much larger Nuvoton, and this is basically a Raspberry Pi compatible. It's a tomato board. Everyone's got to have a fruit or vegetable, so this is a tomato, and it has all the features of Raspberry Pi. It's a bit more powerful. I think it's got 4 CPUs, and I've forgotten. I should have probably prepared better, but in any case, this is, I thought was going to be smaller, but it's a little more powerful than a Raspberry Pi B. The one advantage it does have, I don't have a shield, but it actually has connectors, as you can see here and here, to plug an Arduino shield on top of it. So it's got a Raspberry Pi style GPIO and a compatible shield connector. So it's kind of interesting, and these aren't particularly expensive either. I think it was like $25. So I'm kind of exploring the Nuvoton processors, but I haven't had a chance to actually use them because, as David Anderson knows, I've been building robots. So I have my new differential drive robot. I'll switch cameras before I do this because it's too hard to hold things up to that camera. I was experimenting with second cameras on this Mac. So I think this should just flip over. Yep, okay. So let's see now. In the background here is, let's see now, where's that? So that is my, oh, sorry, it's getting confusing. That's my regular robot, the KR01, and the one I've been doing all the work on. What I've just finished is this one here, which is now called the KD01 for differential. And it uses the same front bumper, literally the same front bumper as this camera's backwards, actually. That's why I'm having trouble. It moves backwards. In any case, this is the front bumper from the other robot. I got another one of these little Makita batteries. This one's a 12 volt with a clip, and it fits in the top there. Why is this thing backwards? It's kind of weird. In any case, I can actually demo it. I was trying to do David Anderson's spin in place test. If I can get the program running. Let's see, motor. Oops, wrong. Hold on. Motor test. Having a little trouble typing with the wrong hand. Here we go. Okay, so got too many computers in front of me. I think that's the problem. Okay, so now, oh, here we go. So I'll just hit the button and start. So this is not rotating in place. It doesn't use PID controllers. It just basically spins. It apparently is trying to mimic David's pirouette because it doesn't actually stay in the same place. It pirouettes. Okay. Unplug this camera. So in any case, that was the new computer or the new robot. And it doesn't seem to really spin in place, but I'm not using PID controllers yet. I'm just running the battery, the motors left to right. Perhaps if I was using PID controllers, it might stay in the same place. But what I'm basically trying to do is that demo that David did in his YouTube video of being able to spin the robot on a table and keep it in the same location. In other words, the hardware works, and then I'll worry about the software. So if I can get the hardware to spin in place accurately, both directions, I'll be happy. One thing about this that you may note is that the drive wheels are these big OSEP wheels, and I built the caster out of a regular caster and put one of these OSEP wheels on the back with a nice bearing. So I'm using a caster that is the same size as the drive wheels. I'm not sure how that will work, but it seems to, it's balanced. It's got a horizontal platform and everything, so that's fine. But I'm not sure in the end if I'm going to end up using this. I might go buy, and there's a little German caster that's quite a bit smaller, and then I can redesign the robot with a small caster if that is an issue. I'm not sure how it will do rotating and then turning again, but this caster has ball bearings on the caster part and as well as that, so it's probably going to be fine. It's not very heavy. This is a 2 amp hour 12-volt battery. I've got the Thunderboard, which is my motor controller, and a bit of wiring underneath the battery, and the Raspberry Pi B Plus is back. It's got the front bumper of the other one, so it's got left and right side, oblique, and a center IR. It will have, once I build it, another one of those little servo-mounted LIDARs that'll peek up through here. And the front bumper is a piece of polycarbonate that fits in the top. So that's the integrated front bumper that runs through the Nuvoton 8051 over I²C into the Pi. Basically, the whole front bumper connects with a single I²C connector. So that works pretty well so far. And apart from that, I think that's it. I am curious about Chris's experience with the IMU, because I could never get that thing going at all, the B&O 85. I had a lot of trouble with it. But I'm going to probably stick with the B&O 55 on this one because so far that's been working fine. Yeah, that's it.
I can go next if you guys think. Okay, so let me present my screen real quick. So what I'm trying to do is to get my robot, give it some waypoints and let the robot move. So last weekend I got the feedback, tuned all the feedback. One thing I noticed, I just want to give you guys like a run log of what I find interesting. So initially I was calculating the speed based on, I have an encoder count, and at every interrupt, I'm assuming, interrupt is 20 hertz. So I'm assuming 50 millisecond, right? And I just divide it. And when I looked at it, well, there's some discretization. So I was thinking it's not a big deal that I'm missing the exact timing of the encoder, but obviously it is giving me, especially at low speed. Well, I started because when I have the motor moving, there's some oscillation, like the wheel is not rotating evenly, although it's a constant speed target. So I was looking in the detail, and then when I say I turn off feedback, just drive it constantly, and I see, wow, it's having this discrete value. I don't know, do you guys see my screen that it's got three discrete value? This is basically the time, and this is my speed, like the encoder divided by time. So then I went in and modified my code so that basically the encoder, where the interrupt happens, it'll know increase count and remember the time. Increase count and remember the time. And then I get the speed from that value. So it's more accurate. Basically, I don't think it can be more accurate than that. And now this discretized value becomes continuous. So that kind of helped. And my design, I don't know if it makes sense. So basically, if I can show you my code, get some critique here. So I have a class that is doing the encoder. And basically, I have that class say get average data. And when it gets the data, it'll clear the cache. I mean, it'll say I'm recounting from 0 until the next time get data. And each time it knows when the encoder increase happened. So, and also the time is microsecond. So that's what got the yeah, that's what got this value. So yeah, that's one improvement. Still, I had when I mount. Okay, this is when I mount. Okay, by the way, just now I took the wheel off, and this is the same wheel. I take it off, it is drifting a little bit. But when I put the wheel back on there, I think it's natural, I guess. But the wheel, each turn has some period, I mean, has some, I don't know what's going on there, but it introduces some dynamics. This is without feedback. So, and I know it's the same period as the wheel turning. But I don't see how I can deal with it. I know my feedback kind of interact with it a little bit because this is low
How
speed.
is wheel balanced?
The wheel, well, this is the mechanism wheel. When you say balance, I see. Is this like rocking? I don't know. How can I balance it? I just have one. Basically, I put it on there, have a set screw to. I'll bring my robot back and show you guys real quick.
That's unusual.
So, I mean, I guess, yeah, if there's a way that I can, like the tire, balance it, that would be good. But the only thing I can do is to put it on and screw the set screw here. So,
Yeah.
Do you have anything that's scraping or rubbing?
not really. This is the particular one that I tested. The shape is a bit different. So this one is more like a sawtooth without this little wiggle in the middle. I'm thinking maybe all these things, I don't know, but I think I'm gonna live with it. But I mean, I didn't really do much. I think it's like once I put the wheel on, and I will see this encoder reading has this periodicity showing up. So yeah, all right. Just want to share with you guys on this. I don't think I can balance this, right? I mean, I don't see anything that I can tweak on here.
If it's, you can like add shim material, like if if the hub wobbles on the shaft with with the set screw loose, that'll take up a little bit of difference. You can even use aluminum foil if
I see.
to
I do feel the wheel a little bit. I can feel it can rock a little bit.
Oh yeah.
Well, not on the shaft. No, I don't think it's the shaft. It's yeah, not sure. But I mean, I think it's good enough for me at this time. The other thing I did on my robot is I added a switch. So before I have to unplug it. Now I have a switch to go. The other one, the other one is I want to share with you guys is I got this odometry. I read up a little bit on the odometry. So I think I got how to calculate that normal wheel. I mean this normal shape of wheel, but this is from a Canon wheel. I took it off from a paper. I'll post the link in that chat here, real quick. So, but yeah, so it looks like, I mean, it looks reasonable with all the 4 wheels showing up in there. This is the Mecanum wheel. But yeah, so what I'm planning is basically in my software, I will have a like odometry object. I mean, odometry module. All the encoder will tell the odometry I changed, and let it keep track of the entire robot odometry. And I have a like a motion planning module that the interrupt will get, I mean, the feedback will get the set point from. So the interrupt will, each wheel will say, what is my speed target? And that motion planning will get odometry. It knows the waypoints. So yeah, for now, I didn't really implement everything, but right now it's like my motion planning is just saying move forward and move back, and I hope I can demonstrate to you guys that it is, I mean, at least the feedback is running. So when I plug it in, it will, oh, yeah, didn't turn on, right? Okay, let me do this again. So it's like 3 seconds. It'll, let's see. It's moving forward. Should be moving back.
Can you hold it up just a little bit? We did.
Oh, yeah.
There we go. Yeah.
I mean, I put it on the floor. It is kind of moving straight, but I really need to calculate my odometry. I mean, hopefully next week I'll have a, like, I'll put a waypoint. It will go really there. One thing I need to calibrate my my encoder rotation angle. I don't know how you guys calibrate. I'm thinking I'll just rotate it like 1,000. I mean, many turns, and then count the encoder, divide by my like a full rotation, come out with a per encoder count, like
you can't get the motor. You can't get the encoder counts from the manufacturer. It should come with your motor, the data, how many pulses per revolution.
Oh, okay.
You should be able to find that information.
Yeah, it's from total. Okay, I see.
Sean, I found it more useful to know the number of encoder counts per inch that the robot travels, and that's easy to measure. Just set the robot down and have it drive in a straight line for 10 feet and count the total number of encoder ticks, and then divide that out, and you'll get however you want to do that, ticks per inch.
I see. Okay, yeah, that solves my
also
the radius measurement too, probably. Yeah. Okay. Yeah. That's most of it. The other thing is, now I need to put my computer on top of this now, right? So initially, I have a. Let me show you my computer. I had bought this NextBook computer. This NextBook computer. I bought it a few years ago with, I think, David Ackley. We're talking about using this as a controller on top of a robot. But this weekend when I tried it, it's really slow. It's a really slow computer. It's like even my small C# program with all the data streaming, it seems too hard to handle. So, but when I'm thinking just throw my laptop on there, but I really have to put a platform to, so that the robot can carry that. So I don't know, maybe I'm thinking about like a cage. But yeah, that needs some work. Right now, I'm thinking I'll just program the waypoint on the chip, and I don't get to real time looking at it. I remember, I think it was Chris suggesting at some point, this connection is difficult. But yeah, so now if the robot is mobile, I think that'll be a issue for me that I have to, on my design, I have a computer in there, so now I have to have the computer go with it.
But John, is it the limitation of the CPU on that little laptop, or is it a communication bottleneck somewhere?
It's the CPU. I think it's running Windows 10. Yeah, I think it's just it's not supposed to be a fast computer. So yeah, but I think
how
it
do you
was
compare that against people who are using like a 16 megahertz Arduino for the same task? I mean, if you're using a laptop that has got orders of magnitude more power than a 16 megahertz Arduino, there must be something that's using up all that computer power.
I mean, I'm thinking just running Windows is a lot of work. So yeah, I mean, look, I have my small program that's just streaming feedback data, displaying it, right? So just that. I ran that, it runs, but it's not responsive. It's like it's responding to the own event, but I can't really do much with that, my own program. So I think maybe I have to put a reduced program. I'm thinking for now, I'll just make the robot mobile and follow waypoints. Maybe later I'll just walk with the robot, carry my laptop with a USB. Then I will think. Yeah, I mean, I think it's gonna be a while before I reach that. The robot is good enough to carry around on its own. So yeah. So yeah, thanks guys. That's my main update. Oh, sorry.
Who's next?
I've got something I'd like to show just for information.
Really have a whole lot.
Let me see if I can get. Now I've got. Okay. If I just wanted to highlight something that I know a lot of people are working with Raspberry Pis. There's a board by Pololu that's very nice, and this is my little Raspberry Pi test robot, and this is they call it an SV. I guess you could call it a shield, but I don't know what they call them on a Raspberry Pi. I'll put a link down here. So this would be it's got
Power controller.
I just put up the link. It has the nice things about it is that it has the motor controllers. It's not an Arduino. I mean, it's not a 328p, but it's whatever. It's the A Star, which is very similar.
It's a 32U4.
Right.
So it has that on it. It actually has some places where you can buffer inputs. It has all of the Pi pins are accessible. All of the was it AU32 pins are accessible. It's even got a little buzzer on it. So I mean, it's really kind of nice, and it fits right on the Pi. And it's I think it's depending on whether you get it fully assembled or not, it's like $30 to $40. But that's if you just want to play around with the Pi, this might be a solution for you. They do have some libraries that you can use. But anyway, I just wanted to, if you hadn't seen this before, thought I would show it.
Yeah, I would also recommend it. I have one actually. In fact, some of us have the Romy, and the electronics on the Romy control board and on that daughter board actually are related. They use the same micro, maybe even the same motor driver. So and you can use mostly the same libraries. So the stuff I'm doing right now with my Romy, again, it's not the exact board you're talking about, Doug, but it's very similar. I'm using again the same Polo libraries, and I have the one you're talking about. Actually, it is a very convenient way of combining the best of Raspberry Pi and the best of not Raspberry Pi. I agree. I mean, the only downside is the I2C link, and I still see occasional errors there, and I don't know what the root causes of that.
Yeah, that's the same problem you always have with Raspberry Pi, and the problem is they can't handle the what do they call it?
Yeah, I thought the Raspberry Pi 4 have fixed that bug, but I'm using a Raspberry Pi 4.
Yeah, I'm not sure it did. But anyway, the nice thing about it is you can make a little test robot very, very simply. I mean, this is just the camera and 2 motors with encoders and Raspberry Pi and the shield, and that's pretty much all there is to this.
Yeah, definitely a nice product. The motor drivers, I don't know the specs on it, but don't plan on driving very large motors with it. But it's it's decent.
They're a 1.2 amp, 2 amp spike or something like that. They're very similar to an L298, though I guess a 298 would be a little bit tougher. But if you're using one of these real small motors, you shouldn't have an issue.
I really like the wooden base. I like the wooden base.
Oh, yeah. I don't know. I just had a piece of wood.
It's easy to work with.
Yeah.
Yeah, I've used plywood before. It's agreed. Wood is easy to work with.
Yeah, this stuff is certainly not make block, but you can get them at Lowe's. It's the holes are spaced a half an inch apart, and it's a steel plate, basically, very thin, but stiff enough for a decent platform base.
And then you cut it to size, or it came in that size?
No, it comes in that size. I have one that's blank.
I've been using a 3mm Delrin plastic, which is pretty much shatterproof. So this is a piece of it. It's not like regular acrylic. It's almost indestructible. I use Woodworking Tools on it, and it drills well, doesn't overheat. You can't crack it. Like it's really tough. And 3mm isn't actually that expensive even in New Zealand, and I've been using that on all my robots, so I can highly recommend that.
Murray, is that like Sintra plastic?
I'm not sure what the actual it's the trade name is Delrin.
Is it a foam-based plastic?
Is it a what?
Foam-based?
No. It's actually a bearing plastic. You can buy white. I built an animation stand back in the 80s and used Delrin blocks and just put stainless steel right through that with a lubricant. You can use it as a bearing. But
like UHMW.
What, pardon?
UHMW, ultra high molecular weight plastic?
No, I don't know what it. Maybe no. It's just a trade name. It's a of acrylic plastic. I don't know what the actual chemical makeup is, but if you search for Delrin, it's very, very common. It's used usually in a white block for bearings, but you can get it in sheet form, and it's really, really durable.
Yeah.
Yeah, I've only seen it in
A
black.
highly tunable plastic. It's actually called acetal. Delrin's the trade name, and it is very dimensionally stable, and it does have a good slick surface. So it's great for making gears out. And I don't remember if you can laser cut it very well, but you can certainly machine it greatly, very, very, very accurately.
Yeah,
Beautiful.
acetal. That's the name of it. Yeah, acetal.
Okay, so you can work it with regular woodworking tools essentially.
Yep. In fact, what I do is it comes shiny like this, and I take the buff off of it with some sandpaper just so it doesn't get fingerprints all over it. And I use regular woodworking tools. I've got an arm saw. I bought. In fact, every time I get a new board, I take a piece of, I guess that's about 3/8 inch, about 8 millimeter, and I make a block of this stuff for every one of my boards to mount on, and I actually cut that on my arm saw. So you can, if you're careful, and, normal care when cutting plastic. But I've used saber saws, regular hand tools, everything on this stuff, and it works really well. And it's incredibly durable. I mean, it's almost indestructible. It's sort of like even stronger than polycarbonate.
Oh, you think it is? Wow.
Yeah, it's really, really tough.
Yeah, I used to work making microprocessor powered power supplies for the robot paint sprayers in car factories. And the company that we built those for, all the parts that they machined for the robot paint sprayers, they machined out of Delrin.
Mm-hmm.
So yeah, it's like he was saying, it's really durable stuff and machinable, and it's good stuff and easy to work with.
Yeah. And so, for example, on this one here, the base plate, there's actually a plate on the bottom that is attached to the OSEP aluminum beams that's made out of black Delrin, and then the top plate is again made out of a piece of Delrin, and you can even cut it down to fairly thin and it won't crack. It's pretty amazing stuff. So I highly recommend it as a building material. I've been really happy with it. I've used it for lots of things over the years, not just robotics.
Yeah, I was just going to show this stuff is from Hillman, and this is another packet. These are strips with holes that are spaced a 1/2 inch apart. You can make simple frames with them that pretty much bolt together, and they're very thin and very light. They always seem to have all kinds of variations of this stuff. It kind of looks like the old Steel Tech, I think, was one of them. A manufacturer of this stuff for like kids' toys. An erector set, I guess.
Yeah, in Canada it was Meccano.
Oh, Meccano? Yeah. Anyway, it's not so hard that it's difficult to drill or to cut. It's easy to grind. Parts of the plate off and that kind of stuff. So. And it's your local Lowe's.
Anybody else? Pretty quiet here.
I'd be happy to show you something real quick. I'm going to show you some really bad PID.
How did you get a copy of my PID?
Hey, you can say if you've been hanging around my 3D printer groups and they're trying to heat a hot end.
Let me present.
Why does my temperature go from 250 to 280 and bounce back and forth all the time? All I did was put in a new thing to do this thing, and I'm like, did you try to do all these other things? What's
really?
that? And can I use hot glue to secure this to my hot end? What are you thinking, man? I get questions like that on the 3D printer beginner group, like, can I use hot glue instead of solder to put two wires together? And you know what? I guess, but you know, it's not going to last very long.
Might work for a while.
Yeah.
Not very conductive.
Well, you just want to hold them together like a solder. They don't
No.
see. They don't want to learn how to solder because they think it's big and scary, and who knows how to do that. And I'm like, it only takes a little bit to be able to solder enough to do what you need to do. You know, maybe you don't have the equipment. Maybe you don't. I don't know. Maybe there's reasons they want to do that. But.
Hey Ray, what is the section to find all these sheet metal and these connecting parts?
Oh, you mean at Lowe's?
Yeah, right.
I think if you just look up Hillman, Hillman.
Humor. Uh-huh.
Yeah.
Okay, that's the brand. That's the brand.
Yeah.
Okay, cool. Yeah, let me check.
They should have. Let me check it out here. Ooh, 4,779 results for Hillman. I think you want to narrow that down a little.
I added in Hillman metal bar and it came up with some stuff.
Oh, it did. Okay.
Yeah, I see it. Thanks.
Turn my microphone off. All right, so this is my team doing a scrimmage match. This is the beginning of their autumn period. These things are called Wobble Goals right here. I don't know if you can see them, the discs, not the discs, but the vertical. They're kind of like Weeble Wobbles. So I'm just going to play it real quick. It's just going to run up here and try to deposit this and then go back to a line.
Sorry. 3, 2, 1. And here you go. Robot's gonna go ahead and drop that Wobble Goal. Take your 10 points. Come on.
What is it doing?
It's gonna get it. Like, see, Robot is like, please. Let's go. There's a mind of its own. It's gonna go ahead and park. Let's go!
Anyhow, that's the really bad PID. So they're working on it. My question is, would you guys be willing to entertain one of them coming on and posing a couple of questions next Tuesday? I'm going to show you one other thing they got in progress at the moment. So this is the CAD for their robot. This up here is a flywheel that's supposed to shoot these orange discs, Frisbees, if you like. And they custom designed this one and machined it themselves, and they've got it to the point where it's partly assembled, just the wheel itself, on nice bearings, and they did it in. They tried to put some more of the weight around the outside so that the angular momentum would keep up when it's spinning the ring out. But this is going to be driven by a fairly high-speed motor. I'm not quite sure what RPMs they're targeting, but hopefully they'll have that assembly that you saw here at least partially put together by next Tuesday. So I was wondering if it was okay for them to come on and present for maybe 5 minutes and get a little bit of feedback from you guys.
Sure.
I like it.
Yeah.
Please do.
Well, the only problem I have is that you're expecting only a little bit of feedback.
He's right. You'll get more than a little. I already have a question or two about how are they flopping the disc type thing.
Yeah, we just did what, 30 minutes on line following tape?
I want to apologize a little bit because I've been a little bit I don't know, in the sarcastic way this entire evening, but and that's just kind of how I'm flowing today. I don't mean anything by it, but it's just kind of how it's coming out.
Well, Harold, I just read that some of the best bourbon is in North Texas. You don't have to go to Kentucky. I don't know if that'll affect your attitude.
Actually, I could use some of that around here. I do have.
And you're going to have 5 days of rain, give or take, so it'll be perfect to stay in. So, yep.
I've got stress building. I've been working on a presentation I need to do on Friday, and so I've got stress building up until that gets done. I'm gonna get a brand new thing. But go ahead. I'm taking over somebody else's time. I don't want to do that.
I don't think anybody's going.
Okay. Well, I'll talk a little bit then. I want to remind everybody. I'm going to put it in the chat that I do a Twitch stream every Monday, Wednesday, and Friday for the most part. And it's 8 to 10. Monday, Wednesday, Friday. Sometimes it runs a bit long. The last couple of times I use it to do whatever I'm doing in the garage, and the last couple of times it's been me building up my my new talk, which is going to be the first debuting on Friday in front of, I don't know, probably single digits of people, but it doesn't really matter how that goes. It's .NET 5 with a slice of pie. So I'm showing you how to use. I'll be showing you how to get started using Visual Studio Code, a Raspberry Pi, and there's a couple different development mechanisms you can do. But basically, setting on your Windows box, having a breakpoint on a running application on your Pi, and being able to debug it over the Pi, and doing all that kind of stuff. How to get started and going, and you're running C# code on your Pi, accessing the GPIO, the whole works.
So you're going to be doing that in your talk, your writing, or you're doing that on Twitch, or both?
Both. I'm developing it on my Twitch stream, but in my talk on Friday. And I should find that link around here, and I'll stick it in the chat here for too long. My talk on Friday will be the whole, the slide deck and the whole thing, and the GitHub and all that kind of stuff. I'm working on that because how this came about was a lot of the stuff I'm doing anyway with the raw stuff and other things. The Arduino IDEs is just a nightmare as far as I'm concerned. Yes, it's okay and it works, but I don't like it. I really like my Visual Studio Code a lot, and so that's what I use for that editor. And then with VS Code, you're able to open up an SSH pipe into the Pi and edit code directly on the Pi from your nice Visual Studio Code on your Windows box or your Mac, or your Linux if you want. It's just sometimes putting a head on the Pi where it's located at sometimes more difficult than not to make sure it happens. So you got a headless Pi and you code things up on it. In fact, that robot head that I've got floating around here, here, let me get that here. This is overhead, me and overhead, close up. This robot head this head that you guys have seen several times, where you can hit a button and it does like a magic 8-ball kind of thing,
I will answer you tomorrow.
The eyes and stuff are Python from the Adafruit kit, but that button and other things like that that's going on is me writing a worker process, playing with Linux and a system control, daemon type stuff, all in C#. That kind of stuff, and that's going to be one of my demonstrations of showing how that works and that kind of thing. And so that's kind of what I've been throwing all together, and having to do that and make that work. It's and then I ask people, hey, do you know you can do this? No. Do you know you just no? Like, hey, let's make a talk about it. I hadn't made any talk in a while, and I'm pretty excited about some of that.
So I've got my calendar open here. I'm waiting for you to put in the time in the.
Give me a second here, man.
No pressure.
Give me a second here. I've got, let me open my Twitter here right fast, because that's where people have been pinging me. There it is.
Doug, are you rolling around on the floor over there or what?
I'm trying to see if I can do this all on my Raspberry Pi so I can have it on a separate thing. And yeah, you can do this meeting on a Raspberry Pi without any problem. That's my Raspberry Pi camera, and I was I noticed it was showing this upside down 3D printer, and I was trying to figure out what in the world. I thought I was on Harold's feed, and then I realized that it was using its own camera, so I have to just get it some way to hold the camera.
Yep.
I know where it goes. Okay, incoming link for those who care.
Yeah, it looks like it'll handle the meeting okay, but like if you try to do anything else, like like something with OpenCV, it won't do it.
So 1 o'clock Friday afternoon. Okay.
It should be noon to 1.
Oh, okay. I was looking at the finish time. Sorry.
Yeah. Noon to 1, and my company Improving sponsors these things on Fridays, and they're always looking for talks and people to come talk and things. And I stuck my hand up because I have to do that on occasion. And most of the time, these virtual events, if you look elsewhere on that page, you'll see other virtual events on that that will have. I'm kind of the reason I'm hemming and hawing is because a lot of times the folks that are doing these things for me or in my company, they're doing like best agile processes or new C# features that will do dependency injection, and they use all these very, very big software type terms. And not that I don't understand them all, and I can use them as well. But what I'm interested in showing off are things like I'm doing in this group here, and showing getting started in other things and using hardware and software in conjunction with each other, which is what I try to do a lot of times on my Twitch stream. When I get done with this, I'll be building my own. Somebody gave me a keyboard kit, and I think I showed that off like a month and a half ago or something. I'm going to be building that keyboard kit to make my switcher happen, so I can switch between my scenes and OBS a lot easier and quicker, and all those sorts of things. And so that's kind of what I'm trying to doing, build together, software and hardware. And the robot is like, I think, the epitome of all that, because it's not just software and hardware, but it's making those things to do something with a purpose that is generally more difficult to do than blinking an LED with a button. So that's probably an understatement, but that's kind of where I'm going with all that. But yeah, Doug, come show up. Everybody's welcome. Everybody's welcome to come see this, and if you're interested in do it, I'm always welcome to feedback on it as well. And again, this is not an in-depth thing. This is not like a 2 or 3 hour thing that we might do on a Saturday here in this group, but it's more like I've got approximately 45 minutes to show you some sizzle and get you interested enough to go try this on your own. This is essentially what I have, and how to get started. And of course, I make this all a GitHub repo. So when I start the talk, I say, here's the repo, and here's all the stuff I'm going to talk about. If you want to continue listening to me, that's great, which most people do. But they can certainly go pick up the all of my notes and all the other kind of stuff, because all that stuff goes in there.
Cool. Thanks in advance.
Hey, no problem. I need to be a bit more noisy about all my stuff that I'm doing, but at the moment I'm stressing just a little bit because I got as annoying and as fun as it was to figure out how to do all this stuff and being able to tell somebody else how to do it, and then making a slide presentation of a decent enough quality that I want to show it to somebody. That's the hard stuff. Finding all the pictures and and really the hardest part is knowing what to not talk about.
Yeah.
What do you throw away? How do you talk enough? But then, because let's face it, any one of these subjects, and I'll take the PID controller thing as much as fun as we like to make about, oh no, not PID controllers again. As much fun as we like to make about that, the subject is so incredibly deep that I think we could have every week do nothing talk about PID controllers in the and the intricacies of all of that, just because the subject matter is deep and large and there's lots to play with, right? But at some point you got to say, no, I got to give them enough to chew on, but then we get to move on. You know, that's kind of hard because I want to be doing. Oh yeah, okay. Well, I can't give them a knitted thing, man. I just can't do that. I would like to, but I can't. You know what I saw this on a cosplay thing the other day. It showed up, and I said, "This is the greatest cosplay ever," and it was the space aliens from Sesame Street when they were talking to phone. You know, the little bring. You know, I just love those little guys. And somebody was cosplaying that, and I go, man, that's awesome. That's awesome. I'd never come up with it. I'd have to come up with that costume if I was going to cosplay, because that'd be the fun thing to do. Anyway, that's me rambling on, and I don't mean to ramble on too terrible, but that's kind of where I'm at. I mean, literally, as you guys have been talking, I've been trying to put words on a slide, not caring what they look like, just say on this slide I want to talk about these things, and organizing thoughts, and that's taken a lot of brain energy to do that. So
well, just to fill up a few more seconds, y'all were talking about Doug rolling around on the floor. Y'all didn't notice on one of the videos about a month ago, but I was looking at something down in my computer boxes on the floor, and I just fell right out of my chair. But I looked at the video later. It wasn't on the video because I didn't have control of the screen. Y'all never noticed. I'm like, oh no, my hand.
Yeah. I will tell you, that's another thing I do too when I'm on the Twitch and I'm doing it, and something gets really either complicated or I don't understand about it. I have to force myself to talk, because there's nothing as interesting as sitting there watching a person go. How interesting can that possibly be?
Yeah.
Mary's giving it to me right now. I mean, I'm just saying. Exactly. That's exactly.
Anybody have anything else they wanted to talk about before I hung up? Carl hadn't come back yet, but not everybody's talked.
Yeah, I haven't said much. I haven't been working on anything, so maybe next week.
Suresh is.
John hasn't talked yet.
Well, I did, but I don't have anything to talk about project-wise, other than I got another 3D printer, which I need to put together. But
so what'd you get, John?
It's in the box, but it's the Micro Center one, the Encore version 2. Supposedly the separate motors are a little bit drier than that, so because they have the version 1, and it's like 180 something.
Okay.
So for about $70 more.
Is it one of those single arm ones that come up and do one of those things as they come out, or is it?
No, it's basically it has the 2 arms with the tross.
Okay.
But it shouldn't be too hard to put together. But I have another printer, so I have a couple to pick from. So
more toys.
I will tell you, I want to get like a Tronxy X5 XS5, whatever. It's their 500 by 500 by 500 Core XY one, because I do want to do some large format printing. It just with everything going on in the shape of my, I don't know, you guys can see part of my background here. Let me tell you about my my cluttered up room. It doesn't get better when it goes off camera. So I just don't know where I'm going to stick it, you know, because I really want to be able to print my own trash can, you know, I'm just that sort of thing, you know.
It may take 12 hours to print, though.
That's okay. That's okay. If I had to go make it, it would take me a week and a half or 2 weeks to make it. That if I wanted injection molded plastic, it'd take me a couple of months. So I'm still ahead of the game.
You know, you can get them pretty cheap from Target.
Yeah, you know, you can buy those things for like $10.
Yeah, but it's not multicolored glow in the dark with with the edge translucent thing that my face shows up when the light comes on in the middle of it. So you can't get that at Target. I'm just saying.
Right.
So you're talking about $100 in just plastic to print this thing.
It won't be that. It won't be $100 for the plastic. Well, I don't know. It depends on how thick you make the walls, right? Depends on how thick you make the walls. Yeah, it could easily run $40 though, a couple of kilograms.
So, Doug, before you hang up, though, be interested to see the next week project if you get the parts for the.
Yeah, I'm anxious to jump on it, but it's going to take a while for the parts to get here.
So, what part is going to take the longest? Is it the foam board that's going to take the while?
Let me pop over there and see.
I know you said it does it by tone sound. So I'm thinking that's the board that's probably going to take a while to get.
I think it's from something from the DF robot. Let me see.
Okay, I would have thought that one would have been faster.
Yeah, let me see here. Do a quick presentation.
Yeah, and if you have the website, you might publish it because I think the other Doug was wanting to have the website.
Yeah. Are you seeing this?
Yep.
Yes.
There's the parts I ordered. And there's that board. I thought that was it coming in here. And oh, that must be the long one. Yeah. That board, and that's a Pi hat that they have or shield for the Arduino, and it listens to the piece that makes the tone. This is the microphone amplifier that will hear the tone and give it to that board. And it uses a little holder for the deal. It's got switches for the bumper. I bought some one-off switches just so I'd have one.
Right.
These servo motors instead of regular DC motors, and I've never used those before, so I thought that'd be interesting. So all those pieces, they had links for where to buy things, but I went to Amazon because that's just the kind of guy I am these days. Even though he's making a fortune, it's like one-stop shopping unless they don't have it.
Yeah. Well, the thing about Amazon, right, and one of those signs that takes so long to get stuff is that when you click on that, you don't know where they're sourcing that from.
Oh, I know.
It'll be sourced right around the house from us since you're all VFW. If we're unlucky, it's sourced out of China, which it doesn't matter whether you get it from AliExpress or Amazon. It's still going to take whatever long it takes.
Right. So the ones that take a couple of weeks, they're clearly coming from overseas. They're not in their warehouse.
Well, I don't understand why not. I mean, doesn't everybody order robot parts like this every day?
I like the ones that you place the order at 9 o'clock at night and they show up your doorstep at 8 o'clock the next morning.
Yeah, there you go.
I had one like that a couple weeks ago.
You clearly don't live in Canada.
No. We're next to a large Amazon DC over in Capel.
No, I order parts off Amazon and it says order now and you'll get it by Friday. Guaranteed delivery date. As soon as you click send or confirm the order, you get an email back saying your order may be delayed.
I forgot you were in Canada.
It's off the Amazon Canada website.
Yeah. So they're counting for the snow and the ice, right?
You did say Northern Ontario, right?
Oh, yeah. Technically, it's Middle Ontario. I've worked in Northern Ontario.
Okay.
So another 500 kilometers north. And surprisingly, they get less snow.
That's up there a ways. I'm wanting to go to Minnesota, and I'm wanting it to warm up first, and it's south of you.
Did anyone happen to observe the SRS mini sumo competition this weekend?
Yeah,
I did.
I watched the whole thing. I think they were going to record it, Dave.
How'd it go?
It was pretty fun. I think people enjoyed it pretty much.
How many robots?
There was 4.
3 people entered, 4 robots.
Yeah, and Donna did a good job of explaining sumo and going over all the parts. And, and it still, got 2 hours for the 4 hour for the 4 robots. I was concerned that if there'd have been 30 robots, that might have been an all-day affair. I don't know how they handle it when they do their the Robothon, which is pretty big up there. So I'm just curious.
It's got to be easier with more people, right? Because she was okay. She had the one guy who was handling. They had one guy who's kind of like the master of the Zoom, and he was handling that kind of stuff. But Donna, she had to weigh the stuff in. She had to fill out the breakdown, the bake-off sheet. She had to push the buttons and then re-push the buttons and then set the robots and explain everything. It's pretty hard to hear one person show.
You did a great job of taking you through the process. I mean, the boxes and the weight and all that. Where if you didn't know anything about sumo, you definitely would know something after she got finished with you.
Carl, I think you're in Japanese movie mode. Your voice is really delayed from the video.
Carl killed my father. I will kill his father.
Really? That's crazy. I don't understand why. I think I have the right microphone turned on.
You have another screen on, so maybe that's it.
I showed some of you my setup earlier. So there's, if you want to understand why I'm so messed up right now, I'm in a different location, and this is my setup at the moment. So you can see there's more than a couple screens to make this happen. So
yeah, and you
it's-
had to haul all those with you.
We just thought where you'd move to, the speed of sound was slightly faster than the speed of light.
I like that answer. It's really good. No, the thing I thought was interesting, I could only watch for the first part of the competition. I could only see. It was hard to listen where I was, but I heard the discussion towards the tail end about some of the different things, and I was interested to hear that. Did I understand right that they had a sumo ring that was actually made with a metal base, and it was specifically done with a metal base so that if robotists wanted to, they could use electromagnets so that they could suck down to the base and get more traction.
Carl, we have one of those.
Oh,
I don't have a metal base.
The DPRG has a steel one, or we had at one time.
We had
for that very purpose, so that you could use magnets.
Huh.
I know the sumo bot's different than the battle bots you see on TV, but on occasion you'll have one of those battle bots, those 100, 200-pound monsters with basically electromagnets in its wheel and it's in its tracks, and they always lose.
Well, there was another trend for a while, which was to do it with vacuum cleaners to suck yourself down.
All right.
And it's all covered in this book. This book is the one that she said was one of their members from the past.
That's Pete Miles. Doug, I think that's
Pete Miles. Yeah. And it was a real eye-opener of a book, because he basically makes the statement, well, you're limited to a certain weight. So the real trick is, how do you get apparent weight? And that's where the magnets and the vacuum cleaners and all of that stuff come into it. And so even though your robot doesn't weigh that much, its apparent weight is a lot heavier. And it's pretty good stuff. I got this used off of Amazon for a couple of bucks. So, if you keep your eyes open, it might be worth it.
Do you think the kids read that cover to cover? I don't know.
Well, I tell you what, I was surprised. Like I say, when I picked this up a couple of years ago, and when I was reading through it, it was like, whoop, I can't believe people did stuff like this. And like they run their motors like way, like 3 times the amps, because they don't care if they don't last very long. They're just, they're really, they got like let's say you got a 6-volt motor, you got a 24-volt supply, you know. So and you know, then wheels is another thing. I mean, all sorts of wheels that to get traction. You know, basically, one I remember is the sort of soft, spongy wheels. So you can imagine if you have all of this stuff going on, it just kind of squats down. You know, it must. Like I say, against true competitors like they probably have in Japan, this is probably pretty wild stuff. What we saw in last Saturday was pretty stock. You know, stock robots. I mean, they weren't even, the only one who was using the weight limit was Donna. She'd obviously made her robots a little heavier. Most of them were, you were allowed 500 grams, and several of them were in the 300 gram realm, which, you know, right off, that's giving your opponent the potential of 200 grams momentum. So anyway, it was just kind of interesting. But I'm afraid that if I ever got interested in that sort of stuff, you know, as soon as I finally got a robot, I'd run into one of these guys with the vacuum cleaner and the magnets and everything. I think the vacuum cleaners came in because some of the courses are not done on steel. Okay. Now I think officially in Japan they're all done on steel. And the supposed reason is because it provides a universal surface for everybody. Okay. You don't, you know, everybody knows what surface they're going to expect.
I think they switched to the steel from, they used to use wood, painted wood.
Yeah.
And they were using glue on the wheels to hold the wheels down, sticky glue.
Yeah.
The other one is when they were using vacuum and suction cups to hold the robot down, it was actually peeling a layer of wood off.
And that's one of the rules. If you damage the ring, you're disqualified immediately. Yeah. That's one of the you know, that struck me too, because you know, we've never had a robot damage our ring.
Well, that prevents you from, you know, screwing yourself to the floor.
Yeah.
There you go. Yeah. Another approach.
Yeah.
Anchors away.
I think what you could do with some, you know, rare earth magnets. You know, you could.
Yeah, I was thinking that myself, though, Ray. You know, they got these rare earth magnets that are so small, and yet they have pounds, like, you know, 200-pound pull. I'm just curious to like what you could do if you really were really into it. But I don't know. You know, I was thinking about this on. It definitely would make you harder to move, but once you get moving, does it buy you anything? But you know, and I believe another Pat, you might know, if I remember, another rule is that if you have magnets, they can't touch the steel. They can be close, but they can't actually touch it.
Well, they can't mark up the steel. It's a painted surface.
Yeah.
So if it scratches the ring,
they fail out. They get disqualified. Yeah. But I know he made a point that he said that, you know, you don't touch the ring. I thought the vacuum cleaner stuff was really amazing, though.
I haven't seen that work. I'm wondering if they use that as a defensive measure, the vacuum cleaner, or is it something that's on all the time with the high-powered motors to move the robot around?
Well, I know they have a skirt. You know, they use a skirt. I mean, at least he said they did. I've never seen the robot. And the skirts essentially just pulls air from underneath and just sucks it down.
Like an indoor hovercraft, probably.
Yeah. So,
well, 50
I don't know. I mean, you know, you got to move the other guy. So the real question would be, I would think, is, okay, if he hits you and you stop, and if he hits you in the front and you got a ramp and you stop he's going to run up the ramp, and then you got him. Okay. So all you would have to know is a sensor that he's up on your ramp. If he hits you from the side, which is where you're weak, that's probably when you suck down. Try to just be defensive. I don't know.
So the little mini Zumo that was running around, that's the speed of the last competition I watched. That was probably one of the slower bots that I've watched.
Yeah, they can zoom around.
So
they do. But I didn't see anybody, or maybe the other guys who watched it. Donna, I think, ultimately won, but I want to say that her robots, even though she had sonar in front, I didn't see anything. Looked like it was targeting. Everything just looked to be random walk type strategies. But in his book, not only do they target each other, but they have countermeasures. For example, they put low density foam on the front so that your sonar bounce, and they angle it. They try to make it like a stealth fighter, so that when your sonar hits it, it just goes away. And they, on the infrared, they had counter infrared measures too. And I can't remember exactly what they did. I don't think they might be just emitting lots of red. I don't know. But
just flooding everything so the receiver can't tell what the hell's going on.
Well, they might be doing that, or scanning or modulating up and down. But it would seem to me that would just make you a bigger target. You know what I'm saying?
Yeah, I got you.
No, you walk off the signal so that they slowly think you're moving in a direction that you're not.
Okay. Well,
that's the same thing that jet fighters do when they get a radar from the ground. They send back slightly out of phase, so it's called walking off the signal. I doubt any sumos actually do it, but they could.
Yeah.
In the early days of sumo, if you go back and look at some of the videos from the 90s and early 2000s, there were hundreds of different approaches, some of them really clever. It seemed like after a while it all kind of narrowed down to basically a shover with a scoop on the front. And is that what these all were?
No, well, actually, two of them looked like the old Pololu big-wheeled side robot with a kind of almost a vertical scoop. And then there was one Zumo-based one that was, I think, a stock Zumo so that has a slanted base. And then there was another one that was a little more sophisticated, which had a base that flipped down. It had a ramp that flipped down, so it would be more gradual. You could get up on the ramp before you knew it. You know what I'm saying? So, so there was only one robot there that looked like it had been modified, and the others looked stock to me.
When you say stock, do you mean that none of these robot builders actually built a robot?
Well, I don't want to go that far because you know how big the picture is on this screen when they're showing the whole thing. It's the robot is about this big, so it's kind of hard to make. But I recognize the parent robot of all of them. You know what I mean? I recognized, they all came from Pololu. I don't know. I'll hold that back. I think those big wheel ones might come from Parallax, but I'd have to look at the Parallax Sumo. But,
so Donna didn't show you any close-ups on the competitor.
She waved it around like this, but I can wave one of mine around here, and you can't hardly tell any. At least I can't tell anything about it. It's I'm just saying but just knowing the available robot kits that are out there, they all look like they had fairly common starting points. Now, what they did to them after that, I have no. One guy well, like I said, I think did a lot of modification. He said that he started off with a Zumo, okay, and he wanted to put. I think he said he wanted to put encoders on it, and he had to talk to the Pololu engineer on how to modify the Zumo base to get the encoders on, if I remember right. If I'm not confusing conversations.
That might have been me, actually.
It might have been you. Okay. But I want to say there were two Zumo bases, and there were two of the big. Donna's were the big wheel on the side robot. Now, let me look up Parallax, and I think I can.
One of them seemed to have the weight a little too high because it kept falling over.
Yeah. I'm still here. I'm not dead yet. I didn't fall over like Doug did. I'm just saying. Yeah. Okay. Yeah. The two that Donna's were started out as Parallax Sumo bots. Okay. So there were two Parallax Sumo bots and two Pololu Zumos. That was the four robots, and it was a fun competition. I'm not trying to, please do not take anything negative on this. I'm just saying that I didn't see any vacuum cleaners or magnets. Now there might have been. I mean, that would have been just a few magnets stuck under the bottom of one of those bases, but from what we saw, we couldn't tell. Like I say, it was a lot of fun, and I would like to see us try something like that. And it actually gave me some idea, some feeling of like we've talked here before about putting maybe a couple of club robots, maybe like some sumo, like Zumos, where people could just program them and compete. The Zumo would do something. We were probably not talking about sumo, but they could be sumo.
Well, Doug, one of the things that occurred to me, I think we might have brought this up in a conversation before, was that that sort of like, I used to go sailing a lot, and obviously there's one design sailboat races, and so it would seem that if you had a lot of local participation, let's say people are brand new to robotics, they went out and bought a Zumo, they compete with the size and the weight limitations and all that, but they're competing against somebody who's maybe heavily modified it with a vacuum cleaner and drop things and all sorts of stealth things. It's kind of unfair. And so if the club was going to go ahead and do a Zumo competition, I would think you'd want to have different classes. So you'd have one where there'd be a Zumo that's unmodified in the sense that you can have any sensors you want, but you can't change the weight and the size, and there'd be certain limitations. And then there might be an open class Zumo that is the same size, but you can do anything, and you can use countermeasures and all that. But you'd probably want to have that initial unmodified with some caveats, so that you could get people in and you wouldn't have to be competing against people with huge, budgets and all sorts of modifications.
We have, if you go back and look at our competitions in the recent past, you'll see that we've had something which we called plastic fastener sumo. And it was for kids. It wasn't for us because none of us have Lego robots. Not that there's any, yeah, and there's nothing wrong with Lego robots. They're cool. But I'm just saying is most of the kids through school have access to either a Vex robot or a Lego robot. And we had this plastic, there was a couple of rules. The rules were like, you couldn't glue the blocks together. You couldn't use zip ties. I mean, a few very minor stuff. And we saw, if you look at the robots, the imagination is out the roof. There's every conceivable possible sumo robot you could make out of Legos. Some of them were not competitors, but hey, that's the way it is. It was great. And you know, if somebody told me how to make, you know, we saw the winning ways. You bake it right up to the weight limit. You put as many motors on that little dude as you can, and you make it as blocky as you can and low to the ground, and you just aim it at the other robot and run it off. Okay, I mean that was the answer, but if you watch the kids, they explored every possible way to build it out of Legos. It was really cool. They had things that flipped down and, you know, all types of ramps and weird stuff, forklifts. I mean, they did it all, you know. So it was really, and they're getting really excited in it. And we probably, I think at our peak, we probably had about 20 competitors. So it was really a nightmare to run it.
Yeah,
I mean,
plugs were not included.
yeah, I mean, whoa, it was crazy. But,
however, their enthusiasm was infectious. If you remember when we held some events down at the Perot Museum, and we would run our normal contests, and we'd have a dozen people standing around watching. Then those kids would do their sumo, would be around that table whooping and hollering and screaming, and a huge crowd would.
Yeah, it was pretty. You're right, Dave. It was something else.
Yep. The exuberance of youth.
Oh yeah. But so that is kind of like, so there's again a bunch of beginners, Murray, and they were allowed free. The problem is, you know, adults would, you know, so one way you could probably get this is maybe say you can do anything you want with these parts. You know what I mean? You can have these, you know, a list of, like they do in the FTC, you know, you just can't put anything together. It has to come from an approved list.
Isn't that how the first competitions work? They give you a box of standard parts.
Yeah, in fact,
that's one group. Yeah,
I believe they call it a kit of parts, and those are all the standard parts you get, and you can do whatever you want to with those parts. But
and it's a lot of money. Those kits, they have to, the teams have to get sponsors.
Yeah, if I remember, my first robotics team I helped was mentoring. I think their first kit of parts cost them around 10 grand or something. I mean, of course, it was serious stuff. It comes with a Robo Rio, a controller that you have to have if you're going to compete the way they do stuff, and a couple of transmission, 6-wheeled bot, all that kind of stuff, geared motors, a high gear and a low gear on that thing, enough motors to drive that 100-pound beast. I don't know that it's going to kill somebody, but it definitely snap an ankle or two to ran into you. I mean, those things aren't playing.
We had a robot.
They're almost doing afraid of us, almost.
Yeah. One of these teams showed, like you're talking, Harold, did a demo for us back when we were on Lady Bird, and they were competing in an arena-like environment that was probably about the size of a half of a football field, half a basketball. Yeah, and they were literally throwing. I don't know if they were frisbees or balls, but they were throwing them up to like a second-story window, and they were getting points for everyone that went through the window. And they were slinging these things from one end of the court to the other because of time. It's pretty.
I saw some of those things were doing some AI and tracking of the balls, and literally the first 2 or 3 would miss. But after it figured out that what it needed to do, where it was, every ball went in that hole.
Yeah, I remember there was that they talked about that. That particular robot didn't do it, but some of the ones they were running up against, they were using some sort of tracking that would correct, so that like the driver, because they were all being driven, if the guy drove it to a certain place and he was off, the robot would keep, you know.
Yeah.
He would turn and then fire.
Some of the newer the last couple of I've only really been involved directly in the FIRST robotics in the last couple of years. They've had an AI section to them. Like for instance, that you don't get any more points necessarily if you use AI to do some stuff, but you get an advantage. Like for instance, they simulated a sandstorm on Mars, and for 20 seconds they had a blind down where you couldn't see anything. So either you had to drive through a little bitty camera that they gave you to look or what to do, or you let the robot do some AI to try to accomplish something in that 20 seconds where nobody else who didn't do any of that stuff couldn't do anything. You had free reign to run around the park. And then after that 20 seconds, everybody comes up and, you know, so it's not that you gain more points necessarily, but you had an advantage to get the points to do stuff where other people couldn't do if you wanted to take advantage of that blind spot using some kind of AI or other means to position your robot ready to score a point or something, that sort of thing. You know, if you could figure that out.
Well, Kareem's been a coach for several teams for 20 years probably.
Yeah.
Yeah, he's
really amazing. I see the kids do stuff, and I'm like, you know, I don't know if that's going to work or not. I'm not going to say a word, but I don't think that's going to work. And well, I'll be damned, I was wrong, because they did the research and they said, yeah, this is going to happen. I'm like, you know, that looks backwards. How's that supposed to work? And I have them explain it to them, and they're like, and after explaining it to me, like, oh yeah, that's great, that's awesome. I'd never thought of done that, but that's going to work just great, you know. And have them explain the thing to me so they learn it better. You know, I may have assumptions or not, but I just try to keep them from chopping off fingers and toes for the most part while I'm there. And that kind of stuff. It's a lot of fun.
Yeah, Osher would have a field day on these robots, I can tell you.
Yeah, it's a lot of fun.
Yeah.
Speaking of, didn't he say he was going to have some of his students come by next week to talk to us?
Yes.
I was repeating that for Carl because he wasn't here.
Okay.
Cool. Thanks.
And Carl, he's looking for a little advice. I told him he's not going to get that.
just a little. Yeah.
I told him he ain't getting a little.
Really, we only want a little advice.
Yeah. Good luck with that.
All relative, right?
Yeah. Hi, all. Suresh here. Sorry to interrupt. Yeah, I'm just getting started on this space, so I'm trying to get ideas. I may not contribute anything in this meetings. I'm just here to get some ideas and get started on this.
Welcome.
So yeah.
If you're here, you're contributing whether you know it or not. So
sure. Yeah. It was great joining this meeting. Thanks, folks. Thanks so much.
Sure. Yeah, your audio is cutting in and out a little bit, but Suresh, just even if you only have one or two questions or nothing at all, just welcome to bring them, and we'll see if we can help you out.
Sure. Yeah. Thanks so much.
It's amazing how Carl can do that without moving his mouth.
Yeah, that's the Japanese.
There he goes.
I don't know what you're talking about.
As I always expected, Carl's ventriloquist.
So if we run the course, I only got here from the very beginning and the very end. So
I think so.
I think so. I know my eyes are getting crossed, and I can't PowerPoint anymore, and I think I'm
all right.
Done.
Enough screen time, everybody. Go back and work on your robots. All right. Good night. Good afternoon.
Good night.
Take care, everyone.
Good guys.
Good night.
Bye.
Night.